But beyond that, insurance company is going to pay for that. But since the insurance company knows that it's not going to have to pay small damages, they charge me a lower premium. So it's kind of a trade-off. I can make zero deductible, but that would increase my, for certain insurance premium quite a bit. So in this case, I could buy an Asian put at K2 113.09, but I could also sell an Asian put So let's think about the payoff of this. Payoff in gross terms. So 114, 1309. Now, I'm going to make this 105.09 to make arithmetic easier. So we have basically three cases, okay? The average exchange rate could end up being above 113.09, below 105.09, and somewhere in between. So let's think about it. Suppose S bar T was above 113.09. So what's the payoff? If you own a 113.09 put and the average exchange rate is actually above that, how much are you going to be paid? Remember, put gives you the right to sell at that price, right? But you don't have to sell it. So if the actual market is above that, you're not going to sell it at 113.09. So the payoff is going to be zero. So this is the long position one. I bought that one. The payoff of the other put is also zero. You know, if the exchange rate is above 113.09, it's obviously above 105.09. So the net payoff, or the gross payoff, is zero. Okay. Now let's think about $1.0509, which is K1. Okay. So payoff of this is going to pay off. So it's going to pay off 1.1309 minus S bar T. This is the long. And this is going to pay off 1.0509 minus S bar T. This is short. So the net payoff is the long payoff minus short payoff. Obviously, these cancel each other out. 0.08, per unit, per euro. So this is, let's call it 0.08, and I'm gonna make that thing dark green. Oops, I'm sorry, wrong place. And you probably guessed that it's going to be like that. This is actually called a bear spread. You do believe that it's going to go down, but not by too much. Again, if it's below 113.09, you're going to make some money, but how much you're going to make is capped at 8 cents. But that's your view. You don't believe it's going to be below 1.09. Well, if it is, you say, okay, I can live with that. But this is going to end up reducing your total option premium. You're effectively telling the option writers, okay, you're going to pay me if it is below 113.09, but I'm going to cap how much you're going to pay me. I'm basically telling the insurance company there's a maximum that you're going to pay me. Insurance companies like that. And if the damage is above $10,000, I'm not going to worry. Insurance company is not going to worry about it. It's kind of a difference from deductible, but the idea is the same. Any damage above $10,000, it's my problem. I don't know why insurance companies do not offer these, but they could. That's what that means. Well, if I tell the insurance company, you know exactly what maximum damage you're going to pay, they'll be willing to charge me less in insurance premium. Laws of probability obviously covers them. And done. Okay? Based on your view, you can do other stuff. You can also do other intervals. That's fine. But this would be a simpler example. On Wednesday, we will start building a spreadsheet that will calculate an approximate price on such options with general weighting scheme. Typically it's very rare that you have very regular cash flows that you want to hedge, but you kind of know what it's going to be. Well, the weeks where you're going to have a lot of payments, that should get a higher weight on the calculation of the average exchange rate. So instead of an equal weighted simple average, we're going to calculate weighted averages. That doesn't change much the algorithm we're going to use. It's just going to change the calculation of the average. Other than that, we're going to use a technique called Monte Carlo simulation, which roughly means generate random price pads using mean and standard deviation of past prices, calculate the payoff for each such realization and average them. Right. Depending upon when the premium is paid, basically we're going to do it in such a way that the present value of the average payoff, depending upon when you make those payments, is going to be zero. Average net payoff. But we need to calculate the gross payoffs first, and from that we can figure out the premium. Which is not terribly complicated, but it requires some computational power. And I'm going to show you how to do it in a spreadsheet, but ideally you would generate the random numbers, these random paths using something like Visual Basic, which I'm not going to get into in this class. For the derivatives class, we're going to cover that. This is going to make it much cheaper and also uses the fundamental principle in risk management. The instrument that you use should be, in a sense, congruent to the risk management purposes you have. In this case, all I care is what's the average exchange rate I'm paying. And I also want to make sure that I'm not paying for too much insurance, in a sense. I don't want to pay for possible that euro-dollar exchange rate is going to be below 0.90. It has happened in the past, around 2001, 2002, but it's very unlikely to happen again. So why would I pay for that possibility? So I'm going to ask my exchange rate people, and they're going to tell me, we don't think it's going to be below 1.0509. Okay, that's kind of my max insurance point. But this is going to reduce the cost of doing this quite a bit. All right? I'll see you guys on Wednesday, and we'll have fun with the Monte Carlo simulation.